Okay, we have used the technology at our disposal to vastly improve the method for making these videos. Here is question 5 from homework number 4. We're going to solve this as an exact differential equation. So, step number 1, identify m of x comma y and n of x comma y, and we'll see something about these two that will identify whether or not this is an exact differential equation. That thing that we are going to see is whether or not the partial of m with respect to y is equal to the partial of n with respect to x. If that is the case, then the differential equation is exact. And here we have partial of m with respect to y is just secant squared, and partial of n with respect to x is the derivative of tan x, which is secant squared x. So we have an exact differential equation. So what that tells us is there exists some function of x and y such that the partial of that function with respect to x is equal to our m of x comma y, and the partial with respect to y is equal to n of x comma y, and we'll just call it function phi. So because we know that the partial with respect to x is m, we will take the we will find phi by integrating m with respect to x. So this is the work to integrate m with respect to x. Notice that at the end we don't have a constant of integration, but we have some function of y left over that we haven't found. To be explicit, the work here, this y, we can pull it out because we're integrating with respect to x. It can be treated as a constant. The integral of secant squared is tangent, and the integral, this can be written as 1 over cosine times sine over cosine, which is sine over cosine squared. Use whatever method, u substitution, for example, u being cosine x. This is the differential equations. You know how to do this by now. So, to find g of y, we know that we'll take the partial of this phi with respect to y and say, okay, well that's going to be tan x plus 0 plus g prime of y. And if we recall, we know that the partial of phi with respect to y is n. So we can take this and set it equal to n. And that cancels out here the tangents. That tells us that g prime of y equals 2y, or integrating, we get g of y is y squared. So we have found what phi is y tan x plus secant x plus y squared, and our general solution is y tan x plus secant x plus y squared equals some constant, arbitrary constant.